Okay, so this is a video about happy numbers, which we're going to do in Python. And what is a happy number? I've just got it over here. Happy number defined by the following process. Starting with any positive integer, replace the number by the squares of its digits and repeat the process until a number equals 1. So basically what that means is that if I open up a spreadsheet here, if we take any number, like any random number, say we take 150, we've then got to, I'll just remove all of the decimals from everything actually, so let's just get, remove all decimals, there we go, so we're just talking about integers now. And we take the sum of the squares of the digits. So here we've got 1, 5 and 0, so 1, 5 and 0, and we take the squares of those. So 1 squared is 1, 5 squared is 25 and 0 squared is 0. So we take the sum of those and we're left with 26. And then again, this 26 here, we take the digits out of that. So 26 is made up of a 2 and a 6. And we take the 2 and we square it, we get 4, and we take the 6 squared and we get 36. And we add these up and we get 40. And then we do the same thing again. 40 is made of a 4 and it's made of a 4 and it's made of a 0. And we take the squares of those, which is 16 and 0, and that's 16. And so forth. So the process continues. Again, that's made up of 1 and a 6. And we square those, which is a 1 and a 36, and that gives us 37. And this process keeps going on. Now, some numbers just go on forever and they never end up getting to the number 1. And other numbers, for example, so if we took like, I don't know, 101, that will definitely be a happy number, I believe. Well, it might not be. Let's have a look. If we took 100, then we could do the sum of the squares. So we'd have 1. Let's do the sum of the squares. So we'd have 1, and we'd have 0 and 0 over here. And then when we take the square of it, that would be 1, and that would be 0 and 0. So that 100 is a happy number. Let's just try another happy number. I'm just trying to and find one that actually converges quite fast. If we take 909, I think 998 was a happy number. If we take 9, so we've got 9, a 9 and an 8, and we've got 9 squared, which is 81, and then another 9 squared, which is 81, and 8 squared, which is 64, and then we do the sum of those, so it equals the sum, because I can't do the sum of those in my head quickly enough. So we've got 226, and that's made up of a 2, and a 6, so we'll square those, which is a 4, and a 36. So that leaves us with 44. That's the sum of that, and that's made up of a 4 and a 4, which when we square them we get 16s each. And if we sum them, that comes to 32. So that's made up of a 3 and a 2. If we square those, we get a 9 and a 4. So 9 plus 4 is 13, if I've added that up right. And then we've got a 1 and a 3. 1 and a 3 adds up to a 4. 4 squared is 16, and so forth. That process continues. It doesn't look like I'm finding a happy number here, although I could have sworn if I did put in a 998, because I was trying some of them, it does get there finally. Actually, I had it looks like I had 2 more iterations, because I got the 98, 226, 44, 32. Did I get a 32 there? Well, yeah, I did. 32, 13. Oh, hold on a minute. That was slightly incorrect there. But so we would have actually got there. That would have been a 1 and a 9. And that would have got to 10. And that would have been a 1 and a 0. And therefore that would have been 1 basically. So the sum of the squares of that is 1. Because 1 squared is 1, 0 squared is 0, and the sum of those is 1. So that is a happy 998. 998 was a happy number, and we've got this process. Basically, we're taking out we're taking out each of the values and we're squaring it and we're adding them up. So it looks like this as well. If I was to sort of like write it out, if we have like 9, 9, 8, what we're actually doing is we're getting 9 squared plus the other 9 squared, and then finally plus 8 squared. That's what we're doing, and we're getting the sum of those numbers. So we're doing the sum of all of those numbers. That's what we're doing, and whatever that is, then we go back into the process and re-break them out into their component parts and do it and so forth. It's not just for 3-digit numbers, it can be for any length of number. So that's just the general process of finding happy numbers. So it's the same is true for 2-digit numbers. For example, well, the number 10 I think was a straight easy one, because 10 is made up of a 1, so 1 squared is 1 and 0 squared. But if, for example, we do 9, I wonder what that gives us. 9 keeps going on and on and on forever. And the process is just like this, basically. So how do we find these happy numbers in Python? We make a little function here called def find happy number, and whatever goes into here, this is the argument that goes in, and it looks like what I've written, because I wrote this a couple of years ago. Whatever goes in here, and I just want to actually do print type of S, maybe I'll do it here. I'll probably get loads of them. Or actually, if I pull up the Jupyter variables, Control J, oh, we can't see the type of S in there. But S will be a list of numbers, I believe, a list of integers for X in string. So whatever we put in here, so that's our string. In fact, do I convert them to for X in string of X? Yeah, it looks like this thing, whatever goes in here, I believe it's possibly its string value. Yeah, it looks like this is just a list. So effectively, we take this string, whatever this number is. So if it's a bigger number, like 999, we take each of the parts. So that's the string of X. So it's actually a string. And then we take each of the elements of the string. There are other ways of doing it as well. But then what we do is we take the sum of these squares, but we want to take the integer of that, because each one of those would be a string. So we take the integer of that and we square it for X in this list here that we've created, and then we return those. So we get the sum. So here is the inner list, each one of the numbers squared. So 9 squared plus 9 squared plus 9 squared, whatever that answer is, and we keep on iterating over that and throwing that back into our function. And this could be done recursively, but recursive methods aren't as efficient as going through loops. So they actually use up lots of memory. So you could get a Stack Overflow. This is a cleaner way of doing it and a faster way of doing it. So we take this number 999, for example, over here, and the next part of it is we create a list. We're creating a list, and we're going to keep on appending to this list. And we just want the first number in our list to be whatever the number is. So we stick that straight into this. So it's not an empty list. It's got a list with one item in it, and the item is it's a starting value. So that when we run this, we see here that the first item is 999, because then we know it's kind of like it's just nicer visually to see it. We could have an empty list. And if this list was empty, it would just look like this. So just be omitting the first number. So it's just something a little bit nicer to have in there. And then we look for happy numbers, and we're looping over, and I've just determined like a range. We could have done a while loop and then sort of like terminated it at some point. But the point is that at a certain number of guesses, possibly we're not finding a happy number and it's just going to go on and on forever. Now we could increase that for like the number 999 and maybe we will get a happy number, or maybe we'll just go to the end number. So, and here we just keep on going. So like, you know, this list is now 1,000 long. I'm not sure that it's necessarily a happy number, and I've just made it 10,000. But basically, I guess we can assume at a certain point that, can I scroll across here? Yeah, you can scroll across the numbers, that if you're not getting a happy number, if it's in some sort of range, that you're never getting a happy number. And it might be some formula for it as well, in terms of, there might be some formula in terms of, or some pattern that you could recognize that there isn't a happy number. And I've not looked into the mathematics of it. I'm just literally doing the coding. But for example, if you get like 42 or 20, maybe if they're evens or something, I'm not sure exactly, but that the squares will never condense to the number 1. So I'm kind of like trying to think what condition that is, because 999 is an unhappy number, whereas 998 here is a happy number. We see that it goes to 226 and 44, then 32, which we saw somewhere else in a oh no, that we saw that actually in our example, then 13, 10 and 1. So that ended up being happy. So if we stuck in 997, let's have a look again. We've got like 10,000 guesses, and we never found a happy number. And we could do something like, we could say that if I'm just what equals 10,000, kind of like, or we could create a loop size, number of loops. We could go up to say 10,000, and we could just stop it like 1 before, because it's always I minus 1. So now we could just go into find range number of loops. So now we're looping 10,000 times, and if I equals number of loops minus 1, then no happy number found. Something like that. It's found. Let's got that right. Found. So we could do something like that. No happy number found. Just to tell us that it's there. Maybe we don't even want to get to the 10,000, but yeah. And then we've got our number, the number of guesses, and obviously if we've got to the end without having found a happy number, then you know the number of guesses is that. And possibly here as well, we could put, if n equals 1, we could put happy number found. So I'll add that in there. So we've got our 2 conditions basically. Either n gets to 1, or we hit our number of loops limits. Happy number found, exclamation mark. No happy number found, dot, dot, dot. We could put no happy number found, no happy number found in 10,000 loops. It doesn't matter. Let's just run that. So again, we've got no happy number found, but if we had our 998, we get a happy number found. So that's generally the process. And what's actually happening here, so we've got this loop and we're looping in this range. This is our little block of code over here inside the for loop. So that's going to keep iterating over this 10,000 times. And we could set whatever number that we wanted to. That's, we just chose to set 10,000. And then we invoke each time we call our happy number function that's in there. So n is the happy number function, the find happy number of n. So we put a number in and we get a number back out. And we keep putting n in and keep getting n back out. And we keep on appending our list just to show. So these are the values. So this is our list, and this is our list of values, and it keeps on getting appended each time we have a guess, and until we either get to one or either of the conditions, which is we end up at the end of the loops, we run out of loops, or alternatively this number that keeps getting recycled back into this happy number method or function returns us back a number 1. So that's basically it. That's finding happy numbers in Python. And I think I might do one piece which is sort of like some sort of extension, because maybe there is a pattern for finding happy numbers, but I'll possibly leave that. So we got like number of guesses here. We had 7. We found 7 there. If we went to 996, again, we don't find a happy number. Does 995 find a happy number? No. And does 994 find a happy number? No. And you can see here that like the first thing that I'm doing is basically 993. I'm iterating through this manually, and straight away we might be thinking, if we're doing that kind of thing, that maybe we can make another function. So def, we could say do the loops. Do the loops. Okay, so we've got this function now. And we might, and this is something that I might do it in a second video, but we could do the loops, and we could put all of that inside, and we could call this function do the loops. Do the loops. So we could call this function, but maybe instead of having n here now, which is outside and doing the loops for the 993, we might make that an argument in here. So n, and we want this to be an integer, so we can type hint. So we can do that. And here we could now then do the loops for like 993, which is still, we can still run this, and we're going to get this not happy number. But what we can then do is put this in itself into a loop, and we can loop over all of our thousands of items and see if we can find happy numbers. So we could do something like for, I guess, I in range, and then let's do a little range. We'll do 100, for example. I in range 100, and we can do the loops function here and like keep on finding it. So we've got loops inside of loops now, which effectively indented loops. So we're calling this function. We should give our functions a name. Find happy number, and we have an argument x, and it gives out a sum. We just call that find happy number, and then something. This function here will be see if a happy number exists. Not really well commented. I'll probably come back and have to re-comment it, but we can go for I in range 100, and this time we can stick in I here, and it's going to do this like it's going to look for the first, for all happy numbers up to, from the number 0 all the way to 100. If we've got a 0, it will still be fine. It will still work, because 0 squared is 0. So 0 squared, well, 0 squared is not going to be happy, because it's just going to go 1,000 times to be 0 and never end up at 1. So let's just run it. We've got this size limit thing that does come out. So we would need to really pass the results of this into a list in itself. I believe that we're totally run on there, but you can see that, so 0 just makes 1,000 zeros, or 101,000 zeros. Let's just shrink this back down to say 100, just to make it a little bit more efficient for all of our stuff. There we go. So we're going to get, we can assume every time we get 101 or something that we're not finding a happy number. But for example, and one thing that we'd want to do is print out the first number, but 1 is a happy number, 2 isn't, 3 isn't, 4 isn't, 5 isn't, so forth. But here we go, we get another happy number here, which is 7. I believe that was 7, yep. So we got a happy number found on number 7. And we could tidy this code up a little bit and find all of the happy numbers, which I might do in the in a follow-up video, because we've got quite far. I've amended some old code that I had before for finding happy numbers, and we could do a full happy number investigation. One thing that we'd want to do is probably not print out this entire list. Possibly also not, well, we might want to show the number of guesses in a nicer way, as in, like, you know, we've got to our limit or we found it in a number of guesses, and we might want to print out the number that we are seeking. So we'll put something like print here an F string. Let's see if I has a happy number. Just to clean it up a bit, so let's see if 0 has a happy number. No happy number. Let's see if 1 has a happy number. Yes, 1 does. Let's see if 2 has a happy number, and so forth. I might actually put a just underneath it, print just a blank line, effectively, just so that they're all separated. So now we can see, let's see if 0 has a happy number. No happy number. Let's see if 1 has a happy number, 2, and so forth, and keep going on. Oh yeah, we get our size limit over here, so we're not going to see it all. But what we can do is pass this into a list in itself. Maybe I will do that, actually. I'll just extend it a tiny bit. So let's just make our happy number list, you know, something like that, which is an empty list, and we'll just populate our list. So because we don't want all of this printed stuff necessarily all there, so we kind of might want to remove our print statements at some point in time. But what we would want, we then need to have a return value that's coming out of here. So print vals, number of guesses, right? So basically, over here, I'm just wondering what we should put. Let's just return at the same point. We'll return len. We'll return what our number of guesses is, because that's kind of like if we found a happy number. Return len vals. So we can do that. We can return that. It's not going to really change the actual function in itself. So return this length of value. So we see here now that we've got this integer coming back. So we could type int into an integer, but it's already going to be an integer. And when we run this do loops, we can now put, so do the loops. Each one of these is going to return something back. So we could do happy numbers list. I guess this will probably be the easiest way. We'll just append our list. I wonder if I should actually have it as a dictionary. Let's put it as a dictionary, because we want our keys to be the values, the items. Although actually, if we were to look at it in our Jupyter Notebook anyway, we'd get that. But we'll have a happy number dictionary, and then our happy number dictionary of I. So each one of those will be, so we're creating this dictionary, and each one of those is going to have whatever gets returned from this do the loops function. And then we could have all of these print statements. It's not so necessary, because we'll see at the end. And I might actually just omit these now, so I might sort of like comment these out, possibly comment this one out and comment this one out as well now. because all we have to do is print our dictionary. So we just have to write happy number dictionary to print it. So that should just work. Our dictionary still, have we got, where am I printing something? Oh, okay, we're printing this out. Let's not even print happy number found now, but we'll just break out of it there. And here we will just pass. Just so that we can get our dictionary at the end. But we do have our dictionary, it has actually been created. And we can see that everything that's got 101 in here is an unhappy number, and everything that is otherwise is not. And what we might do there is we could in theory return, so I think we could break it, instead of looking for numbers that are like 101s, we could actually sort of like return something there. I was going to say return length of values, but here we would actually return the length of values. So we won't actually even break at this point. We would actually just return the length of values. If we did find a number 1, we were done with our function. You can see the break gets grayed out because we're never going to get there now. I'm going to leave that piece of code in just because I'll call it testing method. And here we would return early if we got, well, not return early, but we would return. So instead of getting an integer back, let's sort of like give ourselves a just something like a dash, so that now our dictionary will change slightly and it just have a dash in there. So when we run it now, you can sort of like see that we get a naught and then a dash. We still exceeded the size output of it. Here is the old version of it, but now if we open up a new version of it, we should have our or hit. I guess we could have hit refresh over here actually. If I hit refresh, yeah, it does do it as well. So now wherever we had 101, we've got this unhappy number, and these are our happy number. These are the number of iterations that we had to do to find our happy numbers. And it's kind of like, you know, is there a pattern there? Because for example, 13 is a prime number that's happy. 7 was a prime number that's happy, but it's not a case of that all prime numbers are happy. But it does seem to be the case that, I mean, 19 is prime and is happy. I think 23 is prime and is happy, but then 28 is not prime and it's happy too. So it's not. It doesn't. I'm not sure that there's something that's blindingly obvious that gives a result of happy numbers or not. We'd have to look for sort of like a bigger pattern, but that's generally it. I've sort of modified the original method quite a bit, and we've now got a dictionary of happy numbers. I'll say like in a much more efficient way. I'm actually going to return here not happy. There we go. So we've got run the same thing, and we can hit refresh over here, and now we get not happies or number of iterations. So we can see we've gone up to 99 over there, and we've got this limit. So we've made this assumption. Sorry, our limit was here for the number of loops. Our number of loops here, yeah, our limit was at 100. You know, we might have wanted to put 1,000 in there. So we'll do 1,000. Number of loops 1,000. But still, like nothing, or at least we could have done a count on the array and seen if increasing the number of loops did find like more happy numbers. But I'm not sure that's the case or not. And we could have made our list much bigger now, so go from like to 1,000 and to like run it. And this isn't the most efficient way of doing it. But you can see we've run 1,000 of them. So we're doing 1,000 and we're checking up to 1,000 times on 1,000. So we're finding our first 1,000 happy numbers. And again, I guess I could hit refresh up here. And we're going to say get the same first 100. but then we'll continue on. And one thing that we can do is put any number that is a happy number into a set, and then so if we ever did end up getting 190 as one of our values, that we didn't need to keep computing, because we could stop, because we know that there's only 5 more iterations until we found a happy number. So anything that sums up to 190 is going to be a happy number, will ultimately be a happy number in 5 more iterations time. So that would certainly speed up the code a hell of a lot. And there's a lot of efficiencies that can be put in there. Again, it's kind of like, of every 10 numbers, it looks like a few of them are happy and then a few are not. Here's a whole string of unhappy numbers. That's more than 10 in a sequence. But generally, like a screen full of numbers here tends to be happy. Here's a bunch where there's way more than 10. So a lot of numbers are happy, but not all of them. Here's a whole massive sequence in the 400 section. Maybe that's because 4s are creating 16s, and 16s tend to not be happy. There's quite a lot of 400s that aren't happy there. Is that my hypothesis? Same for the 500s. Maybe as the numbers increase, we get like much longer sequences of not happy numbers. That could possibly be the case as well. So just something interesting to see, and that's generally happy numbers in Python. We created it, we improved our method, and we put a whole bunch of answers into a dictionary on top of everything. So that's pretty much it.